So now that we're talking a little bit more about this idea of end behavior, let's take a look at 4 different graphs and let's talk about what the end behavior of each one of these graphs are. Now in each one of these cases, we're going to have 4 very different end behaviors. You'll see some similarities, but let's take a look at the first example. In terms of determining if this is an even or odd degree polynomial, we know it's odd because we have that one arm up over here and that one arm down. So we know that this is an odd polynomial. And in terms of the leading coefficient, we know that the leading coefficient of this would be positive because it has that standard left arm down and right arm up movement. Now, when we talk about end behavior, here's what we mean. We want to know what's happening to our y values as our x values get really far out. So let's take a look over here. As our x values approach infinity, our y values, and see what's happening over here, see how this function's going up like this? So that's telling us as our x values approach positive infinity, our y values, or f of x, is approaching positive infinity as well. And that will always happen if we have an odd degree polynomial with positive leading coefficient. Let's see what's happening to this left arm over here. To this left arm, now we're going to see what's happening as our x values get really small. So as x approaches negative infinity, our y values, or f of x, is approaching, well, let's see right here. As our x values get smaller and smaller, so we're going lefter and lefter, our y values are going down. So our y values are approaching negative infinity as well. So the end behavior for this graph, anytime you have an odd degreed polynomial with positive leading coefficient, that end behavior is going to be the same. Our x values, as our x approaches positive infinity, our f of x is going to approach positive infinity. As our x approaches negative infinity, our f of x or y values are going to approach negative infinity as well. Let's take a look at example number 2 with its end behavior. Okay, so in this one over here, we have 2 arms up. Now remember, if we have arms up or arms down, that means we're dealing with even. So we know that we have an even degree polynomial. And we know that we have a positive leading coefficient because both arms are up. So this is even positive. Let's talk about the end behavior here. As our x values get bigger, so in this case, as our x values are getting bigger and bigger, so we're going to the right, our y values are shooting up. If you can see, we have that same arm movement from here to here. So as our x approaches positive infinity, our y values, or f of x, is going to approach positive infinity as well. Now let's see what's going on with the left-hand arm. So to the left, our x values are getting smaller. And notice now, still, our y values are going up. So f of x is approaching positive infinity as well. And we'll always have that anytime we have even positive. So an even degreed polynomial with a positive leading coefficient. Let's take a look at these last 2 over here. Here, this is an odd degree polynomial because we have that one arm up and one arm down fashion. So we know that this is an odd polynomial. And not only do we know that it's an odd polynomial, but we also know that the leading coefficient has to be negative because we have the opposite direction of what we normally have for x cubed, left arm up and the right arm's down. So anytime we have an odd degree polynomial with a negative leading coefficient, as our x values approach infinity, so here our x values are getting bigger and bigger, take a look, our y values are getting smaller. Our y values are shooting down. F of x approaches negative infinity. And for this arm over here on the left, as our x values get smaller, because the x values are going to the left, our y values, or f of x, are going to get bigger. So our f of x values are going to approach positive infinity. And again, that's true anytime we have an odd degree polynomial with a negative leading coefficient. We'll end here with this last picture. We know it's even because we have 2 arms facing the same direction. And we know, so it's an even degree polynomial, and we know the leading coefficient has to be negative because both arms are facing down. So this is an example of an even negative. Let's see what's happening here in terms of end behavior. As our x values get big, our y values are getting small. So as x approaches positive infinity, f of x approaches negative infinity. As our x values get small, so here our x values are getting smaller and smaller, our y values are going down, so our y values are going to approach negative infinity as well. So here we have the end behavior for each type, and that's it. You can see that each one is kind of a combination of something else in it, but these are the 4 different types of end behaviors that we're going to have when we're looking at polynomials.